So we're in the middle of a chapter on factoring, and here's what we've done so far. We factored out a common factor, and then we factored something with 4 terms. We did that last time, which was a week ago today. And when it had 4 terms, we did grouping. So I wanted to put up one problem at the beginning of this lesson to remind us of what we did in the last lesson. The reason why I wanted to do that is because if you have trouble with this, then you're going to have trouble with what we're doing today. Because you got to be able to do grouping to do what we're going to do today. So let me remind you of how this problem could have been worked. Because it's got 4 terms, we could group the first 2 and group the last 2, slip a plus in between them. And then we think, well, what could I factor out of 5m squared and 15mp? Well, class, couldn't I take a 5m out of both of those? 5m out of 5m squared would leave m. 5m out of 15mp would leave 3p. Okay, now, do you see that out of these last 2, they're both negatives, and I need that to end up being a positive m and a positive 3p. So to have any chance of getting an m and a plus 3p back here in the second parentheses, I'm going to have to factor out a negative. Negative what? 2. And negative 2r. Let's take a negative 2r out. Good. If I take negative 2r out of negative 2mr, that leaves m. And if I take negative 2r out of negative 6pr, that leaves plus 3p. And now we got what we were after. Our 2 parentheses both say m plus 3p. So one of the factors in my answer is going to be m plus 3p. And the other factor is going to be this stuff out here, the 5m and the minus 2r. So 5m minus 2r. Okay, is that coming back to you from 1 week ago?
And didn't you say like it don't matter how we put
It doesn't matter whether I write m plus 3p and then 5m minus 2r, or 5 minus 2r and then m plus 3p. Either one's fine. I could have written this factor first and this factor second.
Yeah.
Okay. All right. Now, what's that got to do with what we're looking at today? Today, we're not going to have 4 terms. We're going to have 3 terms. For example, here in a few moments, we're going to factor the polynomial 6r squared plus r minus 1. I want you to notice something about this polynomial. It's got something times r squared plus something times r. Notice this is a 1 times r here. And then minus something. So all of our problems that have 3 terms today will be of that form. Something times a variable squared plus something times a variable plus a constant. Usually referred to as ax squared plus bx plus c. If it's not of that form, then we can't use the method that we're going to use today to get it factored. We don't know what to do with it. But all of them are going to be like this, or will turn into this at some point. So, to factor something with 3 terms, there's a couple of different ways this is taught. Sometimes, some teachers teach what's called the FOIL method, which is really a trial and error method. It's a good method. I used to teach it. And if you learned it, and you want to use it here, and you still know what you're doing with it, that's fine. But I don't usually teach it that way now. What I teach is something called the AC method. And the reason I've gone with the AC method is it's a little more of a slam dunk. On some problems it's quicker, on some problems the other method's quicker. But this is a little more cut and dried if you get a feel for what's happening here. So let me give you the big picture behind the AC method. Okay? What we're going to do is we're going to turn this from having 3 terms to where it has 4 terms. And the reason we would like to do that is because if it's got 4 terms, then I can use grouping like I did up here. Use the same idea that I did there. Now, to turn it into 4 terms, what we're going to do is leave the first term the same. And leave it as 6r squared. And we're going to leave the last term the same. We'll leave it as -1. What we're going to do is we're going to rewrite this middle term, which right now is a 1r, an r which is 1r. You say, well, how are we going to rewrite it? And the answer is, I don't know yet. It's got to be 2 things that add up to +1. So we might write it as 6r and -5r. That'd add up to +1. Or we might write it as 4r minus 3r, or 3r minus 2r, or we might write it as 100r minus 99r. But however we write it, it's going to add up to +1. So how do I know how to rewrite it? So I'm going to bust this up into 2 different terms. Well, here's how I know. It's going to seem kind of weird at first. What I'm going to do is take A times C. So the A on this problem, do you see that the A is what's on the squared term? And the C is the constant? So in this problem, A and C are 6 and -1. So I'm going to take 6 times -1, which is -6. And we're going to list all of and we're going to call these factor pairs for -6. That's not very good writing, but that says FACTOR, pairs, factor pairs. And it simply means all the things that I can multiply together that would give me -6. So let's think through that. So 1 times -6 would be -6. Or -1 times 6 would be -6. Can you think of any other factor pairs of -6? Okay, -3 times 2 would give me -6, so wouldn't that mean that 3 times -2 would also give you -6?
Yep.
And that's all of them, isn't it? There's nothing, no other pairs that multiply together to -6. Now what we're going to do is we're going to pick the pair over here that adds up to 1 over here. So if you think about it, 1 plus -6, that's -5, so that's not it. -1 plus 6 is 5, so that's not it. -3 plus 2 is -1, so that's not it. But 3 and -2 is +1. So that is it. So we're going to rewrite that 1r as plus 3r minus 2r, and now we've turned it from a problem that had 3 terms into a problem that has 4 terms. And now we can do grouping. Does everybody see what just happened there?
So you just found something that equal +1.
That's right. Find 2 numbers that multiply together to -6 that add up to +1. All right, well now it's like this problem up here, just like it. So let's do grouping on it. So we'll group the first two, and we'll group the last two. So Sarah and Simon, what would you like for me to factor out of 6r squared and 3r? 3r is correct. 6r squared divided by 3r is 2r. 3r divided by 3r is 1. Nikita and Alexandra, what would you want me to factor out of negative 2r minus 1 so that I could be left with a positive 2r plus 1? Negative 1, because both those signs are going to have to switch. Okay, good. Negative 1 out of negative 2r leaves 2r. Negative 1 out of negative 1 leaves 1. And so my answer is going to have a factor of 2r plus 1 and another factor of 3r minus 1. Boom. What do you think?
It's not too bad, but it's a little more step.
Yeah. It's good. It takes a little bit of time, but the process really isn't complicated. It's just some of the nuts and bolts take some time.
So basically, when you trying to get the answer for like the AC, you take.
Let's try a few more of these just to get better practice, ladies and gentlemen. So this time, let's go 8p squared plus 14p plus 5. Now before you jump in on this problem, let's stop and talk for a minute. There's something that we're supposed to be doing that we haven't been doing. On neither of the two problems that we've done today have I done this, and we really should do it on every problem. Do you remember I said that we should always look for a common factor first?
Mm-hmm.
So on none of the problems that we've had so far has there been a common factor, but we do need to start checking for that because we're going to start having them occasionally. Now in this problem, between 8 and 14 and 5, the only common factor they have is 1. So we don't have to worry about that. Now, you tell me, how do I know I'm doing the AC method here?
You got the square first and you got a constant at the end.
No, that's not how I know. That is a good observation though. How do I know I'm doing the AC method rather than grouping right now? Because I have 3 terms. That's how I know. Okay, so what are we going to do? We're going to turn this from 3 terms into 4 terms. So we're going to leave 8p squared alone. We're going to leave 5 alone. Class, you tell me what a times c would look like.
It's gonna look like 14. Hold on, never mind.
It would be 40. That's right. I'm going to take 8 times 5, which is 40. Now, let's talk about how we know when we got all the factor pairs that we need. How do we know when we've listed all of them? Well, here's what we're going to do. We're just going to start at 1, and we're going to work our way up. Okay, so we know 1 goes into 40 times. So 1 times 40, or negative 1 times negative 40. That'd be 2 factor pairs, right?
Mm-hmm.
Then we're just going to go up from there. So let's try 2. Does 2 go into 40?
Yeah.
How many times? 20. 2 and 20. Negative 2, negative 20. Does 3 go into 40?
No.
No, it doesn't. Does 4 go into 40?
Yeah.
How many times?
10.
10 times. Now, class, so you could have 4 times 10 or negative 4 times negative 10. Now look, most of the time I would quit right here because you see 4 and 10 is going to be the one that adds up to 14.
Yeah.
And once we get the one that we need, there's no reason to go past that.
Right.
But I'm going to on this one because I want to show you how we could generate the entire list for 40 in case we need to. So we'd go up to 5. Does 5 go into 40?
Yes.
Yes, 8 times. So 5 times 8, or negative 5 times negative 8, Then I would check 6. 6 doesn't go into 40. Then I would check 7. 7 doesn't go into 40. And then once I hit 8, I know I'm finished because I've already got the factor pair with 8 in it. 5 and 8. So that's when you know you can quit. Whenever I kind of call it flipping sides. See, I'd have the 8 first and the 5 second. Well, I've already got that.
How do you know which one gets a P? Well, that's the 4 then.
They're both going to get a P.
Okay. Oh, yeah, okay,
Yeah, I need them to equal 14P. If I just put P, say, on the 4, I can't add 4P and 10 because they're not like terms. So they both need a P. So if we're looking for the one that adds up to 14, as I said earlier, 4 and 10 is the combo that we need. So we're going to put plus 4P and plus 10P. By the way, if we put plus 10P and plus 4P, our work getting to the end will look different, but we get the same answer either way. Okay, so now let's do grouping. It's a 10P right there. So how about taking 4P out of 8P squared and 4P? What's that leave inside the parentheses, class?
P and plus 1.
You're both close, but you're both a little bit off.
2P
plus 1.
2P plus 1, okay. And what do you want me to take out of 10P and 5? 5. And then we'll have another 2P plus 1. So at the end of the day, I have 2P plus 1 and 4P plus 5. Now, did you catch what I was saying earlier? Let me illustrate it just in case you didn't. I said it's possible that someone else might have worked that problem and put the 10P first and the 4P second. So is that going to create a problem if that happens? Well, let's see if it would. So if I would add 8P squared plus 10P plus 4P plus 5 and proceeded in the same fashion, then I would have factored a 2P out of 8P squared and 10P. That would have been 4P and plus 5. And then I would have taken a 1 out of the 4P plus 5. So do you see I'm still going to end up with a factor of 4P plus 5 and another factor of 2P plus 1. So it doesn't matter whether you put plus 4P plus 10P or plus 10P plus 4P. You're going to have the same place. Either way, at the end of the day. Whew, what relief. Thoughts or questions or feelings? Simon, how you doing there, sir?
I'm finishing.
So here's another one with 3 terms. And that's how I know we're going to consider the AC method. But do you see that right now this problemo is not of the form that we said? It's not something x squared, something x, constant. But what should we be checking for first?
Like term.
Common factor.
Common factor.
All right, class, is there a common factor in 28, 58, and 30?
At least 2.
2. Yeah.
Okay, 2. And how about x cubed? You can take a 2x cubed out? Okay, let's take a 2x cubed out. So this is the first problem that we've been able to factor out a common factor on since that first day we started factoring. Demetrius, I didn't hear what you said.
You picked the square, the cube, because it was the smallest.
That's right. So that's going to leave 14x squared minus 29x minus 15. Now, what we're going to do then is we're going to take these 3 terms that are left inside the parentheses, and we're going to try to factor those using the AC method.
Okay, so you just
It's going to be out in front as a factor. It's going to come down on every level. Don't throw it away. It's part of our answer. It's one of the factors. Okay, so on the next step, here's what we're going to have. We're going to have 2x cubed. And then we're going to rewrite 14x squared and minus 15, and we'll have to rewrite the negative 29x. Simon,
I was saying that 14 and 2 fit on 7x.
well, I'm not just factoring something out of the 14x. I already factored a common factor out of these three terms up here, and that left me with 14. So I can't take another 2 out because 2 doesn't go into 29 or 15. So we're just going to leave the 14x squared alone for now. Okay, now a times c this time is going to be 14 times negative 15. And if you multiply those, I think you're going to get negative 210. You guys want to double check me on that?
Yeah.
Okay.
Okay, so we only multiply the inside numbers, we're not doing nothing with the outside, that 2x3?
That's right, because it's not part of the trinomial that I'm trying to factor right now. Okay, so let's think about negative 210. Well, 1 goes into it. So 1 and negative 210, or negative 1 and 210. Now, once I find the pair that I need, there's no reason to go any further.
What's the top?
Do what?
What's the top?
What's the top one?
One negative.
That's negative 210.
Ah,
Just the ugly one. The problem is neither one of those add up to negative 29, do they? So that isn't it. Let's try 2. 2 should go into 210. How many times does 2 go into 210, class?
105.
Okay. What about 2 and negative 105 or negative 2 and 105? Do either one of those add up to negative 29?
No.
No. Let's try 3. Does 3 go into 210?
Like
70 times. Okay. Class, 3 and negative 70 or negative 3 and 70, do either of those add up to negative 29? And the answer is obviously
No.
no. What about 4? Does 4 go into 210? No. Does 5 go into 210?
Yes.
How many times?
2 times.
42. So 5 and negative 42 or negative 5 and 42. But wouldn't those add up to negative 37 and 37? Neither of which is negative 29. That's not it. Let's try 6. Class, does 6 go into 210? How many times?
35.
6 and negative 35 or negative 6 and 35. Class, do either of those add up to negative 29? Yes. Yes. 6 and negative 35 add up to negative 29, don't they? That's the combo that we're looking for right there. So we're going to go plus 6x minus 35x. And now we're going to do grouping. Okay, so we'll group the first two, we'll group the last two, we'll put a plus sign in between them. Somebody on my right side of the class, tell me what I want to take out of 14x squared and 6x. 2x. Which is going to leave me with a 7x and a plus 3. Someone out of my left side, what do you want me to factor out of negative 35x and negative 15? Minus 5. And that'll leave me with a 7x and a plus 3. Okay, so 2x cubed is part of my answer. 7x plus 3 is a factor in my answer. 2x minus 5 is the other factor in my answer. And I'm going to drop those brackets now because they'd be serving no purpose at this point. 2x cubed, 7x plus 3, 2x minus 5. What do you think of that? So what are you going to do? You're going to look for a common factor first. Okay? Every single problem, look for a common factor first. Okay, how about one more of these? If I had x squared, let's go with plus 9x plus 12. X squared plus 9x plus 12. What's my a on this problem?
1.
It's 1. That's right. Okay, so it's got 3 terms. I'm thinking AC method. I look for a common factor first, but this has a coefficient of 1, so there's not going to be any common factor. They don't all have x's. So I say to myself, okay, a times c, that'd be 1 times 12, which is 12. And I start to list the factor pairs. 1 times 12. Negative 1 times negative 12. Let's see, those add up to 13 and negative 13. I didn't do it. 2 goes into 12 6 times. 2 times 6, negative 2, negative 6. Those add up to 8 and negative 8. So that doesn't do it. 3 goes into 12 4 times. So 3 times 4, negative 3 and negative 4. But those add up to 7 and negative 7. And then I'm going to flip over to the other side when I go to 4 because there's no reason to go any further because I've already got the factor pair with 4 in it. So you see these are all the factor pairs of 12. None of them add up to 9. What does that mean? Yeah, it means it won't factor, and therefore it is prime. It's prime. So you could run into a prime problem every now and then. Okay, so here is your assignment. Hopefully it's the right page for Chapter 6, Section 3. If you're saying, we didn't do 6.2, you're right. We didn't. How about page 379? '23 through 42. Now we're not quite done yet, so don't cut out on me here. But that's your assignment, along with the other part, right? If you didn't have that for today. By the way, Vanessa had the right idea, right? If you're confused, email to Mr. Black, he emails back. Ta-da! It's all straightened out. Very nice. Okay, I just want to kind of review what we've said so far in this chapter about factoring, because as we do so, it's going to give us a framework from which to work. Eventually what's going to happen is we're going to throw all these different kind of factoring problems in together, and you're going to have to decide, am I going to do grouping? Am I going to do the AC method? Am I going to do a couple of these we haven't covered yet, like the difference of squares or the sum of difference of cubes? What do I do? So as we review, it gives us a platform from which to think when we see a problem. So when we're factoring, remember, you're going to want to remember that the first thing you're always going to look for is a common factor. And we'd gotten a little bit sloppy about that. That was kind of by design because I didn't want to give you too much to think about. But moving forward, we're really going to hammer that point home. We always want to look for a common factor first. Sometimes there will be one, and you always want to factor it out if there is one. Sometimes there won't. Okay, and then here's what we know. We want to look at how many terms that we've got. And so far, we've said that if there are 4 terms, then our strategy is grouping. Yeah. And if there are 3 terms, we're going to use the AC method to turn it back into 4 terms so we can do grouping again. Now, here's what we're going to do moving forward. The next section is also going to be about 3 terms. So we're going to look at a special situation with the AC method. That'll be on Monday. And then we'll look at a section where we have 2 terms. How do we factor something with 2 terms? We'll have 2 different ways of doing that. Then we're going to have a section where we throw them all in together, and you're going to have to pick. And then once we get all that done, then we'll look at what one reason that we learned how to factor. We'll solve something called a quadratic equation. So we're going to have to kind of watch our time a little bit since we missed that day the other day when my daughter was sick. But anyway, that's where we're headed moving forward. Everybody golden? Okay. Have a wonderful day. Thank you.